Let's try to apply these transformation rules to our parent functions. We're asked to do three things in these problems. Sketch the graph, name the parent function, and describe the shift, whether it was left, right, up, or down, or a combination of these. I'm going to start with the second one here. And the first thing I'm going to do is lightly draw out the parent function. And I can see that I have a y equals x squared kind of sitting behind the scenes of this plus and minus. So y equals x squared is the parent function. So I'm going to lightly write out that on my graph. And I know that when y equals x squared, I start at 0, 0. I go over to 1, up 1 squared. I go over to 2, up 2 squared. Go back 1, up negative 1 squared. Go back 2, up negative 2 squared, which is going to be 4 in those cases. So I can sketch myself this basic U-shaped parabola. That is my parent function. So I lightly sketch that first. Next, I need to figure out which way I'm moving and why. So I have my plus 4 here next to x. And whenever something is next to x in the parentheses, or sometimes maybe in the absolute value bars, that's always going to move x in the opposite way of what you'd expect. So I expect plus 4 to move it to the right. It actually moves it to the left 4. So I'm going to go, my new center point is over 4 from where I thought. And then this other part here, the minus 3 at the end moves the y, and it moves the y the direction you would expect. So it would move it down 3 units. Negative 3 goes down 3 units. So I go back from where I last expected my center to be, and I go down 3 units from there. Now I'm going to be able to take my original graph and literally move it to that new location. So if I do that, I will maintain the same basic shape. So if I go down here, I can still go over 1 in each direction, go over 2, up 4 in each direction. And you can see how by understanding what my parent function looks like and understanding the transformation rules, I can very quickly create a new graph. I do not need to make a t-chart to do it. Now, one of the more challenging ones you're going to see is right here and right here where you have the negative out front. So let's go ahead and just do this example together quickly. If you have y equals negative, the absolute value of all of that, you're starting with your basic absolute value of x graph, which is going to look something like this. And we just need to figure out where we're shifting it, and then that we need to flip it over. So the negative down here says flip the graph, mirror it over the x-axis. So after we apply our negative, our graph is going to look something like this. And then the last thing we need to do to finish it off is we need to account for the fact that we have this plus 1 here next to x, which means that we are moving to the left 1 unit. So we go up here like this, and we draw that in our graph, and that would be our final graph on that one. Parent function again on this one is absolute value. Our transformation is that we moved it to the left 1 unit, and let's make sure we insert everything else, and we sketched our graph, so we are good to go. Last thing I want to point out, when you're looking at things like this is considered in the parentheses when it's under the root like that, so the x minus 2, that's causing it to shift 2 units to the right. And then same thing with this log function. You take your basic log graph, and because it is in the parentheses here with x, this is going to shift it to the right 3 units.